Okay, good morning, Camp I Can Meadowvale. So here's your first video of mine on my YouTube channel specifically for you guys. I'm going to look at the power laws today, or the exponent rules as you may or may not have learned them. So a couple things about when you're watching my videos. What I'd like you to do is make sure that you have printed or written down these questions on a piece of paper. So remember that you can pause this video at any time and write this information down in your notebook, or have it printed and then write the information in. Okay, so these files can all be found, and I label them to print so that you know that that's the file that you want to print. Okay, and again, sometimes I'm going to tell you to pause the video. It's important that you pause the video and try things on your own and then come back to the video. So let's see. We had 3 exponent laws, or power rules, whatever you want to call them, as you know them. The first, hopefully you remember some of this. The first one, the product rule, is very simple when we're multiplying. Remember, there's like an imaginary multiplication in there. We try not to show it here because it gets confusing with the x's, the variables. There could also be a dot in there that also means to multiply. Don't forget that. And when we're multiplying powers, the rule is we're going to keep the base, so the base stays the same, it's an x, and we're going to add the exponents. Okay, so if we had something like this with numbers, we would keep the base is a 5, and we would add the exponents, the 5 plus the 3. You don't need to show that step. You are welcome to do that step in your head. Okay, this right here is what we call a single power. So a lot of times questions will say write as a single power and then evaluate, or it might not even have you evaluate. I'm assuming that all of you can punch the number 5 to the exponent 8 into your calculator. So make sure you find that button on your calculator. If you don't remember where that is or don't remember how to do that, that's something I'll have you ask me in one of our meetings. Okay, so we're going to focus on the laws today and making sure you remember them. Okay, next one is called the quotient law. And the quotient law simply says, so that's for division, obviously, the division of 2 powers, simply says keep the base, so the base is still an x, and we're going to subtract the exponents. Okay, so with our example of 5s here, we're going to keep the base, we're going to subtract the exponents, that becomes 5 to the 6th. That's our single power, and if we needed to evaluate it, we could easily punch that into our calculator. Remember, just for your knowledge of exponents and powers, this means 5 times 5 times 5 times 5 5 times 5, so 6 times. Hopefully I got that correct there. Excellent. Okay, and the last one is known as what we call the power rule, or the power of a power rule, and that is sort of when we have an exponent outside another power or exponent, right? They're right beside each other. And so here, of course, we keep the base is an x, and we multiply, so it's actually m times n. I'm not going to write a little multiply in there because it gets confusing. You could put a dot, or I really just want you to know then that this would be 5 to the 16. Okay, 4 times 4 there. Hopefully that makes sense. Hopefully you remember learning those. Let's try a few questions with that. Okay, so again, make sure you have these questions either printed out or written down so you can easily fill in your sheet. And please note the instructions here. That's pretty important. So the idea here is never to use your calculator if there are numbers involved. Obviously, if there are variables involved, you can't use your calculator for everything. But the purpose of these questions is to use your laws to write it as a single power, and then take it as far as you possibly can. Simplify as much as you can, evaluate if necessary at the very end, and I'll show you what I mean as we do some questions, okay? Okay, so here we go. Nice and simple. Hopefully you can see this is a quotient rule. This is a division of powers, and so we're going to keep the base, and we're going to subtract the exponents. 12 minus 7 is m to the 5. And again, you don't need to show the 12 minus 7. You can do that in your head or on your calculator if you need. Nothing else to simplify there because we're dealing with a variable, so we just leave it like that. We write it as a single power. Okay. Now I want to move a little bit more complicated here with number 2. So number 2, hopefully you can see, because the exponent is sort of right next to the other one, right, that it's a power of a power. I'm going to erase that. That doesn't really apply. It's a power of a power. It's our power rule. Okay, now the thing that you got to watch out for in this one is there's also a coefficient. So this also, because it's inside the brackets, also gets the exponent of 3. So if you wanted to rewrite it, you could write this means 2 to the 3, and it means sort of times. We have an x to the 4, and that's also getting the 3. So the exponent or the power of 3 applies to both, and that's the thing that a lot of times people miss. Okay, so 2 to the 3, we actually evaluate that. That's 8. Okay, and then the other one, we have an x to the 4 to the 3, power of a power. So we multiply, so it's x to the 12. Okay, so make sure you have that one written down and watch out for those ones. Okay, now we're going to start to combine it all together. Let's see if it makes sense to you. Okay, number 3. So when it's a little more complicated, hopefully you can see here that we have a power of a power right there. Okay, like in BEDMAS, you would want to do exponents before you dealt with a multiplication or a division or a quotient. So we're going to sort of deal with that power of a power first, okay? And I'm going to write it out completely for you. So don't forget that 4, that exponent of 4 applies to the 2. It applies to the x. And it applies to the y, right? And that's a y squared to the 4. It's a power of a power. So we're going to multiply the exponents, okay? And I didn't show it to you as a step there. That's me showing it how I would on my page. I'm going to write it out all in one step. Okay, and now I have an x to the 3 and a y. Okay. Now I'm multiplying, right? There's an imaginary multiplication right in there. So now I'm multiplying. Now I'm using my product law or my multiplication rule. Those two words mean the same thing. It doesn't matter which one. Okay, but we can only multiply powers that have the same base, right? So we have our coefficients. Our numbers are numbers. We treat them like normal. That's totally separate. Then we're going to put our x's together. And then we're going to put our y's together. Okay, numbers are numbers. 2 to the 4 is 16. There's no number over here. Over here, it's just an imaginary 1, so it would be 16 times 1, which is 16. Then we're going to deal with our x's. So we have an x to the 4 times an x to the 3. And so we're going to keep the base. We're going to add the exponents and get a 7. Then we have our y's. We have a y to the 8 and a y to the, hopefully you knew this, is an imaginary 1. And so we're going to keep the base and we're going to add the exponents. Okay, and nothing else you can do here. This is all multiplication. This is a monomial. This is one term, and that's simplified. Okay, now let's try one more. It would be really great right now if you pause the video and try it by yourself and then see if you get the right answer. This is a much more complicated one, but still good for you if you pause the video and give it a go on your own. Okay, so take a look at my first step here. I applied the power law to this one and the power law to this one, right? This 2 goes to every single piece as an exponent, as a power, and this 3 goes to every single piece as an exponent, okay? And I just left the 2ab cubed the way it was. Now, the only thing that you might be wondering about that, I want to make sure that you've got here, we had an a squared, and that was to the exponent of 2, so it becomes an a to the 4, right? We multiply those powers together, okay? Now I'm going to go to the top. So I'm going to leave the bottom the way it is. The only thing I might do on the bottom is just write it as 2 to the 3, which is 8, a cubed, b cubed, and on the top. Okay, so the top now is similar to what we did in number 3. We're going to do our numbers. 4 squared is 16 times 2, so that gives us 32. Okay, a to the 4 times a to the 1 gives me, keep the base, add the exponents. We're multiplying in here, right? This is a multiply, so a to the 5. And we have b to the 2 times b to the 3. We're going to keep the base. We're going to add the exponents to get 5. Okay, hopefully that one makes sense. And now we have our division. Again, this is doing the quotient rule, and we're going to look at each piece separately. Okay, now one thing to remember here is numbers are numbers. 32 divided by 8 is 4. Okay, numbers are numbers. We divide them the way we always have. Okay, now let's look at the a's. We have an a to the 5 divided by an a to the 3. We're going to keep the base. We're going to subtract the exponents. So 5 minus 3 is 2. B to the 5 divided by b to the 3. We're going to keep the base. We're going to subtract the exponents to get 2. Okay? Once we end up with a coefficient with all the variables, there's nothing else we can simplify. That's a single power, and we've evaluated anything that we could, in other words, all the numbers, and that's it. Okay, so you're going to try some in your textbook. If you need practice with this is something that you can work on, and the questions are all posted for you. Thanks.